First, the bad news. SAP Business AI won't help you generate cubist versions of your family's holiday photos. But it will help you understand which supplier is best to help you roll out your plant-based packaging in Southeast Asia, or identify the training your junior project manager needs to rise up the ranks, and automate repetitive tasks while you focus on big innovations, so you can be ready for the next opportunity. Revolutionary technology, real-world results. That's SAP Business AI.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
And right now, you can save when you shop your faves. Just buy 6 or more participating sale items and save 50 cents each with your card. Baker's, fresh for everyone.
This is SpaceTime Series 26, Episode 134, for broadcast on the 8th of November 2023. Coming up on SpaceTime, could Pluto host a super-volcano? A new study looking at why most Martian meteorites are curiously young in age. And NASA's Roman mission to study the Milky Way's flickering lights. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests the distant dwarf planet Pluto could be home to a massive supervolcano. A report on the pre-press physics website archive.org claims a strange feature on Pluto called Kylides crater has intrigued scientists for years, raising questions about its origins. The study's lead author, planetary scientist Dale Cruikshank from NASA's Ames Research Center, says the feature raises a lot of questions about what's happening inside Pluto to create such a weird landscape. Cruikshank and colleagues believe Kylides is in fact a super-cryovolcano, sending out lava ice flows onto Pluto's surface from deep underground. Cryovolcanism is common throughout the outer solar system. It's been found on several asteroids and on some of the moons of Jupiter, Saturn, Uranus and Neptune. During the New Horizons 2015 flyby of Pluto, several features were earmarked as possible cryovolcanic regions. One of them was Virgil Fossey, located on one side of Sputnik Planitia, Pluto's prominent heart-shaped surface feature. Kylides, which is about 44 kilometres across, lies at the top of the right lobe of the heart shape, in a subregion called Hayabusa Terra. Readings by New Horizons show that Kylides had a lot of water ice scattered around it, and that's unusual because methane and nitrogen ice cover most of Pluto's surface. Also, the water ice contained an ammonia compound, which must have been brought to the surface from deep below in a sort of water-ammonia mixture by some sort of internal heat process, possibly the radioactive decay of elements deep inside the dwarf planet's core. Ammonia lowers the freezing point of water, allowing it to flow as an icy magma through cryovolcanism. Water ice is the primary bedrock on Pluto, and the heating could be creating an ocean of liquid water or at least pockets of slushy water ice. In fact, many scientists are suggesting that water ice or icy slush surrounds Pluto's core. Cruikshank says the ammonia could also be in the form of ammoniated salts or hydrates, and could have been part of the original material from which Pluto was made some 4.5 billion years ago. Pluto isn't the only place where ammonia exists in our solar system, but it is the most distant found so far, although other trans-Neptunian objects are thought to also contain it. Pluto's surface ice is covered with vast regions of methane and nitrogen, and often with the contaminant of tholins. Tholins are hydrocarbon compounds created as the gases from the atmosphere and ice on Pluto's surface are bombarded by cosmic rays and other forms of radiation. While Kylides might have been created by an ancient impact event, the presence of fresh ice and the lack of a thick layer of tholins all point to cryovolcanism as the likely cause. Cruikshank suggests that the Kylides structure is in fact a super-cryovolcano with a resurgent caldera having a history of one or more eruptions ejecting thousands of kilometres of cryolava. He says it's also likely that Pleiades is still relatively young, certainly not nearly as old as the rest of the dwarf planet's surface. In fact, its eruptive activity probably only took place in the last few million years. If Pleiades was old, there'd be a built-up surface layer from a constant rain of organic dust particles from the atmosphere over eons. And that's just not there. This is SpaceTime. Still to come, we ask the question, why are most Martian meteorites curiously young in age? And we look at why NASA's Roman mission will study the Milky Way's flickering lights. All that and more still to come on SpaceTime. A new study has pointed out the curious fact that most Martian meteorites that make it to the Earth's surface all appear to be relatively young in age. Martian meteorites are incredibly rare and can tell scientists a lot about the geological history of the red planet. But one of the biggest issues for scientists studying these meteorites is that it's always been difficult to date them. Different techniques tend to come back with different ages, making it hard for researchers to pin down where on Mars the rock originated. But a new study reported in the journal Earth and Planetary Science Letters may have solved the problem. The authors have placed Martian meteorites in a nuclear reactor in order to confirm their curiously young age. And it's true, most meteorites from Mars are just a few 100 million years old. The study's lead author, Ben Cohen from the University of Glasgow, says scientists know these meteorites definitely did come from Mars because of their chemical composition. They've been blasted off the red planet as ejected debris by massive crater-forming asteroid impacts. The thing is, there are tens of thousands of impact craters on Mars, so knowing exactly where on the planet the meteorite originated from has been impossible to determine. One of the best clues you can use to determine their source crater is the sample's age. While more than 70,000 meteorites have so far been identified on Earth, only 358 of these are thought to have originated on Mars. After being flung into space by massive asteroid impact events, these incredibly rare rocks then swirl around the solar system for ages before finally being caught up in Earth's gravity well and crashing down onto Earth's surface millions of years later. Scientists group Martian meteorites into three basic categories, with a fourth for those which can't be classified. Cassingites are the rarest of these rocks, only two ever having been discovered. Next are the narcolites, which formed about 1.3 billion years ago during volcanic eruptions on Mars. But the most common type of Martian meteorites are those known as shergottites. Around 3/4 of all Martian meteorites are classified as shergottites. They're also thought to have been formed in the roiling lavas of Martian volcanoes, but have formed something of a conundrum because most of the Martian surface is extraordinarily old. Now, based on impact crater numbers, researchers think the majority of the red planet's surface is somewhere between 3 and 4 billion years old. But when scientists try to date shergottite meteorites, they come up with a huge range of ages from 4 billion years to less than 200 million years. This creates a problem. If the surface of Mars is, on average, billions of years old, how then do we get shergottite meteorites coming back with ages of just a few 100 million years? Now, the authors admit that it is possible that the pressure and heat of impact events could be resetting the methods geologists normally use to determine the age of rocks. But as more and more meteorites are being studied by different techniques, the bulk of the results obtained were curiously young, and there's evidence that the ages were not being reset by impact. So clearly something's not quite right here. Martian meteorites have historically been dated using a range of methods such as the argon-argon method, which measures the rate of decay of the isotope potassium-40 down into argon-40. Potassium's an abundant element, making this method very versatile. It's used to measure the ages of a variety of rocks, from eruptions of Mount Vesuvius to the start of the early solar system itself. It's useful for rocks that are formed on Earth because scientists are able to account for contamination of additional argon making its way into the rocks that might skew the age. But things are a little bit trickier for rocks that have been whizzing around space for millions of years. There are 5 potential sources of argon on Mars and in space that can be contained within shergottite meteorites, and that compares to rocks on Earth where there are only 3. The fact that there are these two extra sources of argon in Martian samples is what's making the argon-argon method get complicated for scrutinize. By going back and looking at the argon-argon method with modern equipment and technology, Cohen and colleagues were able to reassess 7 Martian meteorites. This included sticking very small pieces of them into a nuclear reactor in order to measure the argon concentrations as accurately as possible and then seeing what ages they came back with. By looking more precisely at the chemistry of these meteorites, they were able to account for any argon the rocks may have gained while in space. And they were also able to correct the amount of contamination there may have been both from the Martian and Earth atmosphere. Once Cohen and colleagues did that, the argon-argon ages came back as being young and matched precisely with other methods like uranium to lead. The best explanation for the young age of these meteorites is that the frequent bombardment of Mars has created a layer of crumbly rocks on the surface known as regolith, and over time there have been many more impacts into this layer of regolith that's accumulated, while at the same time fresh volcanic eruptions were bringing newer rocks to the surface. This meant that for every new impact, the likelihood of older rock being kicked up and ejected into space was reduced. You see, the older the sample, the thicker the regolith, and the thicker the regolith, the harder it is for the underlying rock to be thrown off the surface of Mars. And that could explain why 3/4 of all Martian meteorites are considered young scrutinize, with comparatively fewer older types of Martian meteorites present. This is SpaceTime. Still to come, why NASA's Roman mission will study the Milky Way's flickering lights, and later in the science report, a bit of good news, with mangrove forests and low-lying islands in the northern Great Barrier Reef starting to expand. All that and more coming up on SpaceTime.
First, the bad news. SAP Business AI won't help you generate cubist versions of your family's holiday photos. But it will help you understand which supplier is best to help you roll out your plant-based packaging in Southeast Asia, or identify the training your junior project manager needs to rise up the ranks, and automate repetitive tasks while you focus on big innovations, so you can be ready for the next opportunity. Revolutionary technology, real-world results. That's SAP Business AI.
NASA's Nancy Grace Roman Space Telescope will provide one of the deepest views ever of the heart of the Milky Way galaxy. The mission will monitor hundreds of millions of stars, searching for telltale flickers that portray the presence of planets, distant stars, small icy objects that haunt the outskirts of our solar system, isolated black holes, and much more. Scientists believe Nancy Grace Roman will likely set a new record for the furthest known exoplanet, offering a glimpse of a different galactic neighbourhood that could be home to worlds quite unlike the more than 5,500 exoplanets currently known. Nancy Grace Roman's long-term sky monitoring will also study how the universe changes over time. It'll join a growing fleet of international observatories working together to capture these changes as they unfold. Nancy Grace Roman's Galactic Bulge Time Domain Survey will focus on the Milky Way, using the telescope's infrared vision to see through clouds of dust and gas that can block our view of the crowded central region of our galaxy. The mission's senior project scientist, Julie McHenry, from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says Nancy Grace Roman will be an incredible discovery machine, pairing a vast view of space with keen vision, yielding surveys that will provide a treasure trove of new information about our cosmos. When Nancy Grace Roman launches in May 2027, the mission will scour the center of the Milky Way, looking for microlensing events. These occur when an object such as a star or planet comes into near-perfect alignment with an unrelated background star from our viewpoint. Because anything with mass warps the fabric of space-time, light from the distant star bends around the nearer object as it passes close by. The nearer object therefore acts as a natural magnifying glass, creating a temporary spike in the brightness of the background star's light. And that signal lets astronomers know there's some intervening object, even though they can't actually see it directly. Now, in current plans, the survey will involve taking an image every 15 minutes around the clock for a period of 2 months. Astronomers will repeat this process 6 times over Roman's 5-year primary mission, providing a combined total of more than a year of observations. Right now, astronomers expect the survey to reveal more than 1,000 new exoplanets, all orbiting far from their host stars, and in systems located further from Earth than any previous mission has detected. Nancy Grace Roman will even be able to detect rogue worlds, planets that don't orbit a star at all. These cosmic castaways may have formed in isolation or been kicked out of their home planetary systems by some sort of gravitational perturbation. Studying rogue planets will offer clues about how planetary systems form and evolve. For example, scientists believe that as Jupiter and Saturn moved out from the inner solar system to their current orbital positions, they caused gravitational perturbations which affected the orbits of Uranus and Neptune, flinging Neptune out beyond Uranus and slingshotting a possible third planet in the system out of our solar system completely. Roman's microlensing observations will also help astronomers explore how common planets are around different types of stars, including binary star systems. The mission will estimate how many worlds with 2 host stars are found in our galaxy by identifying real-life Tatooine planets, building on the work started by NASA's Kepler Space Telescope and TESS, the Transiting Exoplanet Survey satellite. Roman will also find brown dwarfs, those objects which fill the boundary region between the largest planets and smaller stars. Studying them will allow astronomers to explore the differences between planet and star formation. And Roman's expected to spot more than 1,000 neutron stars and possibly hundreds of stellar mass black holes. These exotic heavyweights form after massive stars exhaust their fuel supplies and collapse. Black holes are nearly impossible to find when they don't have a visible companion to signal their presence. But Nancy Grace Roman should be able to detect them even if they're unaccompanied, because microlensing relies only on the object's gravity. The mission will also find isolated neutron stars, the leftover cores of stars that weren't quite massive enough to become black holes. And astronomers will also use the new telescope to find thousands of new Kuiper Belt objects, icy bodies scattered out beyond the orbit of Neptune. All of these scientific discoveries and much more will come from Nancy Grace Roman's Galactic Bulge Time Domain Survey, which will account for less than a quarter of the observing time in Roman's 5-year primary mission. Its broad view of space will allow astronomers to conduct many of these studies in ways that have never been possible before, giving science a new view of an ever-changing universe. This report from NASA TV.
Almost all observations of the universe come by collecting light in various wavelengths. This light can show variations in brightness, reveal structure in cosmic objects, and contain huge amounts of information in how its wavelengths are distributed across a spectrum. Researchers have captured these details for decades, even centuries, but often they are limited to just a brief snapshot of an object in space, a single still image. In recent years, scientists have been making more observations with a fourth component, time. Space isn't static, and recording data through a given duration, called time domain astronomy, tracks how details of an object, like brightness, spectrum, location, and structure, change. An object can vary, it can move, or it can do both. There are 3 main classes of how an object can vary in time: periodic, quasi-periodic, and transient. Periodic change means there is a regular, fixed pattern to the change. Sunrise and sunset, or a blinking pulsar are examples. Quasi-periodic means that there is a pattern, and the change or event happens again and again, but not as regularly, like hurricanes or flashes from hot material around black holes. Transient events are less predictable and often happen only once. Earthquakes and supernovas are transients. These are the hardest to observe because they can be brief and start unexpectedly. If telescopes aren't looking in the right place, they miss the beginning or even the entire event. NASA's upcoming Nancy Grace Roman Space Telescope will be specially equipped to be a groundbreaking tool for time domain astronomy. It will observe from space, so it won't have daily time restrictions like ground-based telescopes, which can only observe at night. It will have image quality like Hubble, but with a field of view at least 100 times larger, so it will be able to observe large portions of the sky all at once. Roman is a survey mission, which means that in addition to a large singular field of view, Roman can repoint that view more efficiently during observation periods, tiling even larger areas of sky 1,000 times faster than Hubble. For one of these, called the Galactic Bulge Survey, Roman will aim its expansive view at the center of our galaxy and observe a 2 square degree region in infrared wavelengths that cut through the obscuring dust to reveal millions of stars. During this survey, Roman will take a new image every 2 minutes for more than 62 days, and then repeat this 6 times over 5 years for a total of 400 days of coverage. Roman will be watching for planets transiting or eclipsing their host stars, and rare gravitational lensing events where gravity of foreground objects lenses the light of background stars, causing changes in brightness. These peaks can reveal new planetary systems, rogue planets untethered to a star, and even black holes that would otherwise be invisible. A single snapshot of the sky can't show these events. They require constant or very regular monitoring to reveal. Roman's main objective in this survey is simply finding new planets and black holes. Astronomers anticipate that Roman could discover over 1,000 microlensing and 100,000 transiting planets from this survey alone. Observatories like the James Webb Space Telescope can then follow up with a narrower, more targeted view and learn key details about the most interesting discoveries. Roman will also perform time-oriented surveys aimed at furthering our understanding of the universe's history and future. With its wide and steady gaze, the Nancy Grace Roman Space Telescope will be a key player in the future of time-domain astronomy.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that adults who are diagnosed with attention deficit hyperactivity disorder, or ADHD, could be at higher risk of dementia in later life. In 2003, the authors used an Israeli health database to identify over 100,000 people born between 1933 and 1952 who had not yet received a diagnosis of ADHD or dementia, and then followed up with them until 2020. The findings, reported in the Journal of the American Medical Association, show that in that time, 0.7% of participants were diagnosed with ADHD. And within that ADHD group, 13.2% went on to develop dementia during the study period. At the same time, only 7.1% of participants who did not receive an ADHD diagnosis went on to develop dementia. Now, although this type of study can't show that ADHD caused an increase in dementia, the researchers say the findings contribute to existing research suggesting there could be a link between the two. Meanwhile, scientists warn that people aged over 50 with ADHD are being overlooked when it comes to diagnosis and treatment. A report in the journal Expert Review of Neurotherapeutics says the current diagnostic criteria have no specific consideration of how ADHD presents in older adults. The researchers looked at 100 studies, including 44 in older adults. They found that none of the studies observed people over a long period of time going into older age. Instead, the studies tended to ask people about their childhood symptoms, which can be unreliable because of age-related memory issues. Bit of good news now. Scientists have found that mangrove forests in low-lying islands in the northern Great Barrier Reef are expanding. The findings, reported in the Journal of the Proceedings of the Royal Society B, combined field surveys and canopy height models to map the mangroves of the Howick Islands and estimate their growth since the early 1970s. The study's authors say that over the past 50 years, the mangrove forests have grown up to 5 metres a year, adding over 100,000 tonnes of biomass to the region. The researchers say this is likely in response to environmental changes, including sea level rise, cyclones and sediment transport. The new mangroves create new habitats and protect the island's coastlines. Apple releases its new M3 range of processors, claiming they're the world's most advanced computer chip, a new smart health system for your beloved pooch. And see how the other half lives at the Sydney International Watch Fair, where you can snap up a bargain $1 million wristwatch. With the details on that and more, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, well, this is their third generation of their M-class processors based on the ARM processors used in the iPhones and iPads. This is sort of the supercharged desktop-class processors. And for those who like to wait for version 3 of something before buying, this is a perfect time. Rendering speeds are 2.5 times faster than on the M1 family of chips for video. The CPU performance cores and efficiency cores are 30% and 50% faster respectively than those in the M1. It's not as fast compared to the M2 in terms of, how much faster it is in the M1, but that's because the M2 came out last year. And if you've been waiting, from your Intel machine, this is obviously a much bigger jump. In fact, compared to Intel, this is 11 times faster than their Intel-based machines, depending on which one you got. If you have an older Intel machine, it'll be faster still. And then the neural engine, the AI component of the new chips, is 60% faster than the neural engine in the M1. So, look, this is obviously Apple wanting to boost its sales of Macs, and also it's their answer to what Qualcomm launched last week when Qualcomm launched their X-series ARM-based processor for Windows computers. I mean, that was Qualcomm's answer to Apple's M-series chips. Qualcomm's ARM chips for desktop computing haven't been anywhere near as impressive as Apple's. And in fact, Qualcomm purchased a company that was made up from ex-Apple engineers, some of whom worked on the M-class series of chips. And Qualcomm did say that their processor was faster than the M2. So it's telling, and it's interesting that a week later, Apple has launched processors that eclipse the M2 in speed and should be blowing the competition out of the water. And on top of all of that, you can now purchase Apple's M3-based computers, and the first orders will arrive in less than a week, whereas Qualcomm's processors won't arrive until mid-2024. So definitely good for Apple. They've got new MacBook Pro 14 and 16-inch models. They've gotten rid of the 13-inch MacBook Pro. And there's also a new iMac, which didn't get the M2 chip, but now gets the M3. So if you were looking at getting a Mac or upgrading from your Intel Mac, now's a good time. But of course, if you don't buy one now and you wait till next year, then with the M4, it'll be even better.
There's some smart news for people who love their four-legged friends. If you have a fur baby.
Well, actually, this is a smart health system that helps your dog in this case. It's for dogs. They have a smart wearable, which is like a Fitbit for dogs. They have a connected smart bowl, and they also have this home hub. And what it allows you to do is to track the health of your dog, when they sleep, make sure they get the optimum amount of food, track their needs and quirks and behaviors. And you can do all this even when they're not home. Look at their food intake, again, look at how they play and sleep, and even tell how your dog is feeling. So, look, I was at JB Hi-Fi, which is a bit like Best Buy in the US, and I was there to purchase a hard disk, but I looked on one shelf and there was a whole stack of pet tech, so connected wearables for your pets. But this is a Melbourne-based, an Australian startup called iLume, I-L-U-M-E, a personalised pet health system. And they say it's a world first. So, if you've got a Fitbit for yourself, you can now get one for your dog.
And finally, if you've got enough money, $1 million for a Swiss watch.
Yeah, in Sydney on the 2nd, 3rd, and 4th of November was the Sydney International Watch Fair, which had 9 luxury Swiss watch companies, most of which you've probably never heard of. There's a company called Rebellion Timepieces, which only started 4 or 5 years ago, but already they're the official timekeeper for Dakar. They're the official timekeeper for the Alfa Romeo F1 team. They have Ronaldinho, the Brazilian football star, as their ambassador. They had the Revolt, which is a $1 million watch with 330 baguette-cut diamonds. And a lot of the watches at the fair were analog-style watches, but incredibly detailed. These are sort of the anti-digital smartwatch, the anti-digital watch, of which there are many now. You even have Rolex, who makes 5 million watches a year, but these 9 Swiss independent luxury watchmakers, you'd be lucky if they make 5,000 watches altogether. Normally they have runs of 80, 90, 100, 200, 300 maximum of a particular model. So obviously you're talking about watches that are tens, if not hundreds of thousands of dollars to purchase. But
these are people who have their own private business jets, let's face it.
Yeah, it's for people who want something special and different, and it's a peek into a fascinating world that most of us sadly will never be able to afford to purchase. But
Alex, let me ask you straight out here. Did they give you one as a free sample?
No. You do. It's not the sort of thing where you get a free sample, but it's certainly something if you want to see how the other side lives, it's a wonderful example of that in action, and it's capitalism at its finest.
And what else is on the website this week?
Look, I have plenty more articles at techadvice.life. There's some new augmented reality glasses. There's a lot of the video interviews with the people manning the stands at the Sydney International Watch Fair. There's the behind-the-scenes video of how Apple filmed its Scary Fast event using iPhone 15 Pro Max instead of expensive cameras. And so please come and have a look and check it out for yourself.
That's Alex Zaharov-Reut from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.